So here we are being asked to prove that the determinant on the left hand side, that is equals to this 1 plus p xyz into x minus y into x into y minus z into z minus x, where p is any scalar. So p is a constant actually. So therefore the de determinant on the left hand side, that we can call it as some delta, that is equal to x square 1 plus p x cube y square 1 plus py cube, then z square 1 plus pz cube. So that can be written as x square 1 y square 1 z square 1 means determinant of x square 1 y square 1 z square 1 plus the determinant of x square px cube y square py cube and z square pz cube pz cube pz cube, that will be equal to, so x square 1 y square 1 z square 1, then plus the determinant of, from here from the third column we can take p as common, then from the first row we can take x as common, from the second row we can take y as common, and from the third row we can take z as common. So this will be pxyz into the determinant of 1x x square, then 1y square, 1z square. So then this can be written as the determinant of x square 1 y square 1 z square 1 plus pxyz into here if we interchange the third column and the second column, then the sign of the determinant will change, and then again if we interchange the second column and the third column and the first column, then also the sign of the determinant will change, and so the sign will remain the same. So it will be x square 1, then y square 1, z square 1. So here what we did, we have interchanged the first, here we have first interchanged the second column with the third column, and then we have interchanged the third column and the first column. So the sign will remain the same. Now this determinant, we can call it as some delta 1. So it will be delta 1 plus pxyz into delta 1. So that will be delta 1 into 1 plus pxyz. So then this delta 1 we have to find, that is the determinant of x square 1 y square 1 z square 1. So therefore delta 1, that is equal to x square 1 y square 1 z square 1, that will be equal to, now here we have to subtract the first row from the second row. So it will be R2 goes to R2 minus R1, and then you have to write R3 goes to R3 minus R1. So that will be x square 1 y minus x y square minus x square 0, then z minus x z square minus x square 0. So then from the second row we can take y minus x as common, and from the third row we can take z minus x as common, and into that we can write x square 1 y plus x 0, and then 1 z plus x 0. Then we can expand this determinant along the third column since it has two zeros. So this will be y minus x into z minus x into 1 and 2. So this is A13. So this will be y plus x minus of z plus x. So this will be minus of z minus x. So x and x will cancel here. So this will be y minus x into z minus x into y minus z. So now therefore the value of the determinant on the left hand side, that is delta, which is equal to, we got it as delta 1 into 1 plus pxyz. So that will be equal to 1 plus pxyz into, I can write it as x minus, this we can also write it as x minus y into y minus z into z minus x. So here, sorry, this will be first, this will be plus, this will be minus here. So since it will be z plus x minus of y minus x, okay, so this will be z minus y, okay. So this will be into x minus y into y minus z into z minus x. So which is equal to the right hand side. So hence proved. So hope you have understood. Thank you.